This video is all about reversing of DC motor, prepared by me. So, to reverse the motor, you need to change the polarity of the supply voltage to either the field winding or the armature winding, but not both. Generally, it is better to reverse the field voltage because the field current is less than the armature current. So, your reversing switch gear is more lightweight. So, DC motor control reversing. So, this is the actual picture or sample. So, DC motors. Electrical motors are actuators that convert electrical energy into mechanical energy in the form of a continuous angular rotation that can be used to rotate pumps, fans, compressors, wheels, and etc. There are basically two types of conventional electrical motor available: AC and DC motors. First, AC motors are generally used in high power single or multi-phase industrial applications, where a constant rotational torque and speed is required to control large loads. In this article, we will look only at simple DC motors, which are used in many consumer and industrial applications. So this is the picture. So DC motors. The DC motor is the most commonly used actuator for producing continuous movement whose speed of rotation can easily be controlled, making them ideal for use in applications where speed control, servo type control, and or positioning is required. A DC motor consists of two parts: a stator, which is the stationary part, and the rotor, which is the rotating part. Basically, there are three types of DC motor available: brush motor, brushless motor, stepper motor. So on-off control. A DC can be controlled in various ways. The simplest being the on-off switch, which allows control of the motor only the maximum speed of rotation in one direction, switch on or stop switch off. This control can be implemented with a switch, an electromechanical switch, a MOSFET or a BGT transistor, and a freewheel diode necessary to avoid back EMF damage to the rest of the circuit, as the DC motor is an inductive load. So, concerning an SSR solution of this kind of control, the connection is exactly the same. In fact, the DC SSR outputs are designed with FITs or BGTs, allowing the connection of the DC SSR on either side of the load, as shown in the following pictures. So, this is the diagram DC. So next, high bridge. So to run the motor in the opposite direction, it is necessary to reverse the polarity of the current flowing in the motor using a circuit called an high bridge. It consists of four control switches connected as shown in the picture below. So this is the picture of diagram. This is the positive and then the negative. So the key fact to note is that there are four switching elements within the bridge. These four elements are often called high side left, high side right, low side right, and low side left in clockwise order. Activating switches A2 and B2 provide current flow through the motor in one direction while activating switches A1 and B2 provide current flow in the opposite direction. So, another video. It's already close. The A2 and B1. And the next diagram, the A1 and the B2 is closed. And the opens the rest. The following truth table shows for each of the switch states what the bridge will do. There are 16 possible states. So, this the possible states. Motor off all, A, A, A1 to 2, then B1 to 2 is already off. Then the motor off for A1, A2 off, B1 off, B2 on. So then the third one off, off, on, off for motor off. Then off, off, on, short circuit condition. Then off, off, motor off again. Then off, on, motor brakes and decelerates. Then off, off, motor goes counterclockwise. Then off, on, circuit, short circuit condition. Then on, off, motor off again. Then on, off, on, motor goes clockwise. Then on, off, motor brakes and decelerates. Then on, circuit condition, short circuit condition, then the rest, short circuit condition again. So that's all. Then next, dynamic brake function. Dynamic brake function. The two blue rows of the table describe a technique where the motor is deliberately short circuit after removing power by closing either the lower two or upper two switches as shown below, which uses the motor's generator effect to work against itself. So this the diagram. So generating into essentially a short circuit causes the motor to stop spinning rapidly and is called dynamic braking. So PWM function. If speed control of a DC motor is if desired, in addition to on-off and reversing, the DC voltage source can be varied, which can be difficult and expensive, or it can be accomplished through the use of poles with modulation PWM or PWM if using solid state switches or SSRs. RS. So this is the diagram. So this means basically to send a square wave at a certain frequency to control the switch, as shown in the previous pictures, the previous. On A2 when B1 is closed, on B2 when A1 is closed, the controller is essentially opening and closing the switch at very high rates, from 200 Hz up to 20 kHz. So in inductance, the motor is neither fully or on or fully off, but somewhere in between at a slower speed. Note that motor torque under PWM remains the same with whether fully on or only a percentage on. Varying voltage speed control reduces torque, usually an undesired effect. So next, soft start, then stop function. This is a modified start where the DC power supply is applied to the load using a PWM with a duty cycle going from 0% to 100%. So this is the diagram, or I mean the pictures of 0 to 100%. In the graph, the green line is the control voltage of the switch. So the green light. Then the red line is the average voltage on the motor. Soft start ramp at time in the duration of this PWM ramp used to avoid initial inrush current and abrupt motor movement. The same applies for the soft stop function. During the ramp time, the PWM goes from 100% to 0%, producing a soft stop without mechanical jolts. So, reverse, the red line is going down.